Welcome back. We have a connected particle problem here, and it reads, a body of mass 6 kilograms rests on a smooth horizontal table. It is connected to another body of mass 10 kilograms hanging freely by means of light inextensible string which passes over a smooth pulley fixed at one of the edges of the table. The string is taut. Determine the acceleration, the tension in the string, the reaction on the 6 kilogram mass, and finally the reaction on the pulley when the system is released from rest. This is the diagram that has already been explained in the question. We have a 6 kilogram mass that is resting on a smooth horizontal table, and we have a 10 kilogram mass that is hanging freely. So when this system is released from rest, what you have to know is the 10 kilogram mass is going to accelerate downwards, while the 6 kilogram mass is going to accelerate along the table towards the pulley. This is the fundamental that you have to understand regarding a system like this. So the force that exists in the string is called the tension. Let's label that. We have already said that when this system is released from rest, the 10 kilogram mass is going to accelerate downwards and the 6 kilogram mass is going to accelerate along the table. Regardless of the mass, a system like this will cause the object that is hanging freely to accelerate downwards, while the object that is resting on the table to accelerate towards the pulley. So, solving the question, let the 6 kilogram mass be M1 and the 10 kilogram mass be M2. For the 6 kilogram mass M1, the only horizontal force that is acting on it to cause motion is the tension. So which means for the net force you only have the tension. Therefore, I can say tension is equal to mass times acceleration. Tension will be equals to M1 multiplied by A. If I should substitute the value, I will have tension equals to 6A. This can serve as equation 1. Okay. So for the 10 kilogram mass, we can call it M2. If you analyze the diagram, because it is going to accelerate downwards, it means that the weight is greater than the tension. Okay? In this situation, we have two forces. You have the weight and the tension, but because it is going down, it's going to accelerate down, then the weight will be greater than the tension. Weight is greater than the tension, so it means the net force, which is going to be the difference, will be equal to mass times acceleration. We know that weight is equal to mass times gravity, so that will be M2G minus the tension is equals to M2A. The mass is 10, gravity is going to be 10, unless stated otherwise, minus the tension is equals to 10 times A. So 10 times 10 is 100, minus tension is equals to 10A. I can call this equation 2. So what I can do here is to substitute equation 1 into equation 2. Substituting equation 1 into equation 2 what is equation 2? It is 100 minus tension is equals to 10A. So that will be 100 minus tension. We got that as 6A in equation 1. This is equals to 10A. So 100 is equal to 10A plus 6A. 100 is equals to 16A. To find A, you divide both sides by 16. Both sides by 16. A is equals to 6.25 meters per second squared. So because I have found A, I can use that to find the tension. So from equation 1, tension is equals to 6A, then that will be 6 times A is 6.25. That will be 37.5 newtons. If you want to use equation 2, you can use it. If we want, we can also use equation 2 to find the tension. And so we can say from equation 2, and what is equation 2? 100 minus T is equals to 10A. 100 minus T is equals to 10 times the acceleration is 6.25. Then we'll have 100 minus T is equals to 62.5. So to find T, I will send it to the right side of the equation and bring 6.25 to the left of the equation. So that will be 100 minus 62.5 is equals to T. And 100 minus 62.5 is 37.5 is equals to T. Therefore, T equals to 37.5 newtons. You can always go in for the simpler equation to find T, okay? You are not obliged to solve T using both equations. Just any one of them will be enough. All right. So we have answered the first question, which is A, and we have also answered the second question. Okay? Now, let's go in for the third question, which says the reaction on the 6 kilogram mass. So what you have to understand about the reaction is it is the perpendicular force that is acting on the object. We call that R. So for a body that is on a horizontal table or a horizontal surface, the R is always going to be equal to the weight. So therefore, because we know that weight is equals to mass times gravity, therefore R is also going to be equal to mass times gravity. Okay, so let's find the reaction. Question 3, R is going to be mass times gravity. The mass is 6 and gravity is 10, so that will be 60 newtons. Question 4 is asking us to find the reaction on the pulley. Okay, so the reaction on the pulley will be the force that will act like this. Let's just call it F. So to find the reaction on the pulley, we know that there are other two forces acting on the pulley, which is T and the T that we have here. And T, we got it as what? 37.5 newtons. So 37.5 newtons, 37.5 newtons. So if we should extract that, this is how we have it. You have T here, you have T here, and you have F. T is 37.5 newtons. We can close this as a triangle by bringing F like this and using the T here parallel to the line T here. So it means the triangle is going to look like this. You have 37.5 newtons, 37.5 newtons, and you have F. Whenever you have something like this, Pythagoras theorem should come to your mind. So F squared will be equal to sum squared of the other two sides. So that will be 37.5 squared plus 37.5 squared. That is going to be 37.5 squared is 1406.25, then plus another 1406.25. That will be 2812.5. So to find F is going to be the square root of 2812.5. F is equals to 53.0 newtons. So that is the reaction on the pulley. Thank you very much. If you are new to this channel, please subscribe, like, and share the video. Hit on the notification bell so that whenever a new video is uploaded, you can be aware of it and watch it. Thank you.